Hi there, and welcome to Powerfully Digital Q&A. My name is Rob Potter, and I'll be your moderator today. What I'm going to do first is just introduce you to our team today. So I'm going to start with first, which is Philip Herman, who will introduce himself.
Yes, hello everyone. My name is Philip Herman. I'm Market Segment Director at Danfoss Power Solutions. I'm located in northern Germany, Neumünster. That's also from where I'm broadcasting right now. And in my role, I'm responsible for strategic marketing as well as business development for the construction market segment.
Perfect. And I'd like to introduce you now to Aleister Robertson, who's based in Scotland.
Hi everybody, my name is Aleister Robertson. I'm a product portfolio manager here and I'm based in Edinburgh, which is the home of digital displacement technology. And I'm involved in various early stage customer projects and customer development.
Perfect, thank you, Aleister. And then I'd like to introduce you to Craig Grant, who's also based in Scotland.
Yeah, hi everybody. So Craig Grant, Sales Development Manager for Digital Displacement, mainly looking after the European accounts. So looking forward to having some of your questions.
Right, thank you, Craig. And then very last but not least, Lee Mallam, who's based in North America.
Good morning, everybody. Lee Mallam, I'm the Business Development Manager for North America and South America, and I'm responsible to help support business development, commercial issues, and some technical issues. Looking forward to working with you.
Right, thank you guys. Right, we'll get on to our Q&A. So first one we have today, Craig, this is one for you, please. You know, Danfoss has invested so much into digital displacement. Can you tell me why there's such a focus here for them?
Yeah, I'll take that question. So Danfoss have a long history with digital displacement, going back some number of years, and they really wanted to take this technology into a commercial environment within the mobile industry. So it was seen as a new product development, something new that Danfoss can offer to the marketplace. And it also brought in the opportunity to satisfy a market that wasn't particularly a strong one for the Danfoss group, which was within the medium to heavy excavator market, sort of 15 to 35 ton tracked excavators. And that potentially will bleed over into other industries, but that's where the primary focus was and where the real interest started from. So hopefully that's given a brief overview of why the interest.
Thank you, Craig. Yeah, I really appreciate that. Aleister, one for you, please. Nice and simply, we've heard a lot about the future possibilities of excavator with DDP. Can you explain why there's such a maybe bright future there for us?
Bright future in excavator. So from a Danfoss point of view, it's a market that Danfoss isn't really present in. So from a Danfoss strategic point of view, it's a new area for us to get into. And in a way, it's a showcase of Danfoss and their desire to bring new technologies to the market. So not just new technologies like DDP, but also electrification. And to bring what are differentiated products to what are really quite challenging markets to address energy concerns. And really, I think there's a big picture view here of trying to bring new technologies to the market that really help tackle our customers' needs for energy efficient products in the future.
Perfect. Thank you, Aleister. One for you, please, actually, Philip. Basically, there's a lot going on potentially around electrification and DD, and some of them may have missed that presentation today. Can you just give a quick overview of what DD electrification could come and bring together?
Yes, sure. Thanks for the question. Overall, electrification is obviously a big topic in our industry, and it's something that we need to accomplish in order to achieve overall global emission targets within the off-highway market in general, but construction market in specific. What we see, though, is a big barrier being in the high costs associated with that, especially coming from the batteries required. And we have heard a lot about the efficiency of digital displacement and related system architectures, which in the end will have a direct and significant impact on the sizing of the battery for construction machinery and other off-highway machines. So we lower dramatically the commercial barriers by being able to lower installed battery size by 20 up to 50%, depending on the system architecture. And really seeing this as an enabler to ramp up the adoption of electric machines in the market in the years to come.
Right, thank you. Lee, we have a question for you, please. Basically, we've understood there's 1, 3, 4 outlets. Can you explain, is there a reason why there's not 2?
Yeah, well, I mean, there's no reason there can't be a 2-outlet version of the pump. It's just that the customers that we've worked with so far, we haven't had a need for a 2-outlet. When we run into those situations where we need a 2-outlet, and I don't know if the person that asked the question was in my session today, but I talked about ganging blocks. So that's where we would put a hydraulic or an HIC on the outlet ports and electrically gang 2 of the ports or 3 of the ports or separate all 3 ports. So the pump is it's elastic enough to be able to do 2 ports with a 3-port version, I guess is how I could describe it. But again, if there's a need for a 2-port, yeah, we should be able to do that in the future.
Perfect. Thank you, Lee. Cheers for that. Craig, one for you, please, is that when will more displacements be available?
Yeah, hopefully at some point, either during Eric's presentation or in Neil's, they've mentioned that we will have a family of products coming out. Just now, the focus is pretty much on the 96cc moving into next year, but following behind that will be our 180cc pump, which will develop into a family, come down in size to 150 to 120, but it's a back-to-back pump, so ultimately that's 360. Timescales on that, it's still difficult to say exactly when because our focus is on 96, but it will be a fast follower beyond that, and we're actively engaging with customers just now to explore where the market is for this pump and what other sizes we need to put in our portfolio.
Perfect. Thanks, Craig. Aleister, actually a really good question here for you, please. This is taken from one of our presentations today that the chart showed efficiency at just over 90%, and there was mention of not having the use of case drain. So if it's so efficient, what is causing this 8% loss and where's it all going?
Yeah, that's a good question. So I guess I would always say we're not magic. We're a hydraulic machine. We've got the usual kind of friction and leakage losses that you might expect. They're just an awful lot lower. So one of the reasons that our efficiency is so high is because we're only enabling cylinders that you need to meet the load demand. So instead of maybe in an axial piston machine, you're changing the stroke, but you're not able to offload any of those cylinders. If you've got a 9-cylinder barrel, then they're all pressurized and they're all leaking when your machine's pressurized. In a DDP, that's not the case. If you're down at low displacement, then you're only leaking through the cylinders that you're actually using. So, if you're at 10% displacement, your leakage is only coming from 10% of the cylinders being used rather than partially using all of them. I guess some of that energy has to go into bearings. We've still got bearings. We've still got churning losses. You're still moving oil around in that crankcase a bit, and that just takes a bit of energy. In terms of the case drain, there is some leakage through the mechanism from high pressure to the low pressure side, as you'd expect. We've got pressurized wetted areas, and you have to have some leakage past those surfaces, but it's very small, and it's simply a re-intake through the intake side of the pump. So you don't have to carry it away. And because the loss is, let's say, 1/10 that of a conventional machine, you're not looking at significantly high power flows there that you need to deal with by providing cooling flow through the machine when it's operating. Hopefully that answers the question.
Yeah, it is. Thank you for that. Phil, actually a great question here for you, please. When we're looking at sort of DDP and electric motor, what's the potential solution lineup here?
Yeah, indeed, good question. I think, first of all, obviously, both technologies and both products are available today in the market and can be applied both on machines. But if we think about a complete solution that we also aim to offer to the market, of course, that's one of the priorities for next year as we apply this to machines, whether it's excavators and wheel loaders, to make sure we have an optimized solution with both products in terms of controllability software. We talk about +1 compliance, but also all the mechanical interconnections. I think that's the next step that we want to achieve, that we can have some tailored, optimized electrification, Editron, and digital displacement solutions and subsystems we can offer to the market for targeted applications in the near future.
All right, thank you for that. Lee, a really good question here. We obviously get asked many times, what is the difference between a DDD pump price and that of a traditional hydraulic pump?
Well, yeah, you're right. We do get this question a lot. And what I can tell you is that today we do not have a list price or a standardized price for the product line. We're working on developing that because this is such a new product line for us, and we're still trying to understand the value of this product line to the market. So as we learn all that, we will develop a price that's applicable for the application that that the customer is that we're trying to apply to it. It's going to be a value sell, there's no doubt, but it's usually a pretty easy value sell.
Great, thanks for that, Lee. Aleister, one for you, please, and it's around the sort of production capacity for DDP right now.
As in, what is the production capacity at the moment, I assume?
Yes, correct.
So at the moment, we have a pilot production facility based here in Scotland, and what we would say is that we have a nominal annual capacity of something like 2,000 pumps per year, and that's kind of all types. So the single, the multiple outlet, and the tandem pump. We can build all of those and combinations of those pumps. So you can have a single and a multiple outlet common together in a tandem. Those are all capable of being handled by the line. If you got really excited about DDP and you decided to place some kind of big order and with a target for middle of next year, we could maybe think of pushing that up by around 10%, maybe some just 2,200 pumps per year, something like that.
Cheers.
But I should say there's just I was going to say it's the first step, and this is where we are basically building up from where we're at now with this brand new technology. We're working directly with OEMs. It's kind of pilot productions, and we're trying to get that viewpoint into the market of how to scale this technology. And that, I should say, is the ultimate goal, is to be not a niche player technology, to be a truly a technology that's available at high volume in the marketplace, making a significant impact for our customers.
Okay, right, thank you. Craig, really good question here. So basically, how does a DDP compare to a conventional piston pump, an off-the-shelf product?
Yeah, looking at that question, I think Lee's answered the second part of that question quite well, but just to reinforce, it's not a commodity, it's not a Me Too product. But with regard to reliability, yeah, traditional technology has had a long history. I mentioned it in my presentation. It's been around since the 1890s. This is a newer technology. We have got hundreds of thousands of in-house test hours against our pump. It's mechanical. We know where the potential weak spots are with regard to bearings. So we would expect bearing life to be the same, if not better, than conventional pumps. And we currently have products out doing field test trials in real life applications. So we are confident it will at least match the same durability as existing products.
Yeah, thank you, Lee. One here for you, please, Aleister. Nice and simple. So have we looked at pairing a DDP with a BFD to increase motor efficiency in terms of industrial applications?
Yeah, that's an interesting question, and it does come up quite a lot from the industrial sector, because there it's quite common, certainly in injection molding and maybe presses, things like that. You see variable frequency drives being used with either an axial piston machine with swash angle sensor and pressure feedback, or just a simple gear pump or a vane pump to give some kind of energy saving solution where the speed's reduced down very low in order to make sort of fairly significant energy savings. I would say that from our point of view, we'd say that's a relatively expensive solution. And the DDP comes at this from the viewpoint of just using a very simple high efficiency class induction motor and a soft starter. And there's no need to reduce the speed of the DDP to make those savings. And then the DDP is always at its at its working speed, and you don't need to ramp the motor up in order to be ready for a flow demand. So it's in a way it's a much more simple system where the motor and the electrical side of things are pretty conventional.
Right, thanks, Aleister. Philip, actually a question here for you, please, around sort of automation. So obviously looking after the construction segment, is Danfoss doing any sort of automated excavator work right now? Is there anything that we've looked at as a business?
Well, that's a good question, and something that can be answered quite extensively. I think machine automation is, of course, in general, a big topic in the construction market. There are many degrees of what automation autonomy actually refers to. What I can certainly say is that machine automation is one of our focus areas in power solutions in general. We're also specifically looking into this with regards to the construction market. For example, we see a lot of benefits in road building applications, for example. Specifically on excavator, as of today, there is no active project here, but definitely something we are looking into, and where potentially also the benefits of a digital pump like the digital displacement can help us achieving some functionalities that would be maybe more challenging to accomplish with conventional systems. So
Right.
it's somewhere on our general autonomy roadmap, but that's all I can say about this right now, and no further details.
Perfect. No, thank you very much. Aleister, I've got two questions here around sort of service and maintenance. You know, how easy is it to service and maintain this pump? Is it a complicated process compared to conventional?
So I would say at the moment, compared to conventional pump, because we're in this kind of ramp up phase and we're working directly with OEMs, we don't have, I don't know, let's say service kits that are commonly available. I think at the moment, we're working very closely with the OEMs. If there's any issues or anything we need to solve, it's done in close collaboration with that customer, and maybe pumps can be brought back here. I would say, you know, looking further into the future, I think we've all been saying that this is the start of the journey of DD technology out into the world. And I think so on the one hand, we have a controller that can provide you diagnostic feedback, or maybe even prognostic, you know, tell you something's happening in the pump before it actually manifests itself as a change in the way that the pump operates. And that can be fed back into either an OEM data acquisition system, and I don't know, let's say alert the operator to take the vehicle in for servicing or something like that. But then at a component level in the future, I would expect that we offer, I don't know, valve rebuild kits, bearing kits, rotating group. There's no reason, I don't think, why that shouldn't be available in the future. But just now, I think for these early releases, we are concentrating on the sort of more simple to replace things. Let's say the wiring looms, the sensors, shaft seals, the sort of items around the outside, and if anything more deep than that's required, then at the moment it would be brought back to here.
Right, thank you, Aleister. Lee, I've got a question for you, please. You know, simply a DDP, what's it sound compared like to, you know, axle piston machines? Is there a difference there?
Yeah, I mean, there's a difference. The one big difference is on an axial piston pump. You guys are probably very familiar with that, the whining sound that you get when it goes into high pressures, even at low pressures, but it gets more intense at high pressure because of the radial design and how the valves are actuating. The pump has more of a, I don't know how to describe it, maybe like a ticking sound versus whine. And it's a more, you know, the customers we've worked with, they say that it's a much more pleasant sound, and they're actually surprised how better the quality of sound is, especially in an industrial application where you have people working around it. So they're very impressed and happy with that sound. And then when it's at comp, I mean, or when it's offloaded, it makes no noise, zero noise. I mean, matter of fact, some of our customers, even in industrial applications, they'll take off the access plate and take a look inside and look at the coupling to see if it's even running, because they don't believe it's running. So it's a different sound.
Okay, thanks, Lee. Aleister, I have a question for you. In terms of like the more output pump, what is the flow fluctuation?
So I guess this is kind of maybe a question probing at the fundamentals of DDP and how we make flow. And it's kind of, in a way, it's a, you could probably spend quite a lot of time talking around this, but I think what this question is getting at is an understanding that we are creating flow by pulsing individual cylinders. So in a conventional machine, an axial piston machine, you've always got 9 cylinders or whatever it is, 11 cylinders, and you're going to get a flow ripple that's fairly constant because you've always got these cylinders connected to the load. Whereas in DDP, you can imagine at zero displacement, we literally have 0 cylinders firing. At full displacement, you've got all, let's say, 12 cylinders firing, and in the middle, you've got some kind of pattern being played on these cylinders, producing pulses of flow into the system. I think what you've got to do is kind of step back from that, though, and realize that really you've got, per every second, you've got hundreds of cylinders that you can choose. When you're maybe, I don't know, 1500 or 1800 RPM. So really from one way around this is to say that our algorithm is quite smart in the way that we choose the cylinders to fire. And the other is that the system plays a huge part in it. So I can't give you an answer and say that DDP is perfect. Of course, there are some instances where we can cause a resonance in the system, or we can do those things. But that's part of our technical expertise, is to work with you as our customer and to get through those problems. And the kind of backstop statement that I've got is that in every application we've done with every customer, we always come to a solution. It's partly software, it could be system changes or valve changes, but we have to engineer our way around this. So I can't give you a perfect answer that says DDP is a perfect flow source and it's smooth under every condition. It isn't that simple. But really, that's our job as engineers, and really the competency that you get in working with us is that we're here to help you in your application make DDP, not just work for you as an OEM, but also get what your customers need out of that application. And maybe the question there was asking about bigger machines. Maybe that means bigger cylinder sizes, and that goes into a whole technical debate that we could probably spend quite a lot of time talking about. We do internally, and there's always some kind of compromise. But maybe as machines get bigger, you could, on average, say that systems are getting bigger. So, the problems may be scaling with the size of the machine and the size of the pump, and they kind of move up in lockstep, something like that.
Perfect, thank you, Aleister. Craig, a really common question here about obviously mounting issues. With the design of the DDP, does this cause any issues to the OEMs? Is there any design changes that need to take place? How have things been for DDP?
I think it's safe to say we have to take each one in its own merits. There'll be some applications where the pump goes straight in. There's been others where just because of a pilot pump, it's causing a fouling issue, and we have to work around that. I think the benefits that the pump gives, back to the system in productivity and efficiency, and the ability to look at actually redesigning the circuit, maybe making the cooler smaller, things like this, changing the valve types, allows people to sort of approach the whole architecture in a different way. So, yeah, it's not a put it in and it fits straight away, with the existing technology. I'd be surprised if that was always the case. It'd be the same in any sort of technology. So yeah, we've worked through those. It's a bit like what Aleister says. We find the problem, we work through it, and come out with a solution. We probably have that end game in sight as to where the customer wants to go with the project. And we're at early stages with the customer that we can manufacture that space in, because we're in the early stage of the discussion.
Right, thank you for that. Aleister, I have a question here, and actually maybe something for Philip, you to tap into too. How about the current available max rated speed of DDP? Is it high enough to avoid gearbox between electric motor and pump? Will it be beneficial? No cost, noise, efficiency perspectives. What's our thoughts there, Aleister? And Philip, please chime in afterwards.
So I would say our upper rated speed is somewhere around 2,600 to 2,800. Where you could check out the data sheet that I think's in the folder on this, in the kind of waiting area for this stream. So that's our upper speed. You can maybe vary it a bit with some boost pressure, but I think it should be about in line with electric motors, but maybe, and also maybe depends on the duty cycle a bit as well, and whether you're running continuously at high speed or whether it's for short periods. Philip, do you want to pick up on the electric motor side of things?
Well, I think, as you said, it very much depends, right? And as we heard in the previous answers as well, I think we need to have a thorough analysis of duty cycle, specific machine, and then typically solutions possible. And in those cases where we looked into this for different excavator sizes, we can see a solution. But more analysis to be done on a case-by-case basis, obviously.
Right, and I think that's something where it's quite difficult to give sort of generic answers to a lot of these questions. And I think we'd encourage you to get in contact with us with your application. And really, between the team here and the team at Editron, we can probably take a look at your application and see what the needs are.
Great, thanks, Aleister. And I think that's a good point here. We've got about 15 minutes left on questions, and they're still rolling in. So any that we don't get to, we'll make a point after the event to make sure. Also, within the platform itself, don't forget that you can actually go in there and arrange a meeting with one of our team, and they'll happily pick up any more of these discussions at a later date. So please go back in there, look at the plan a meeting, and you'll see 4 of our experts who will gladly take a call. This is a big one, Craig. We've had a few questions here. I'm looking at my list around energy recovery. Is this a topic that's combined with DD? What's coming in the future potentially?
Yeah, I think I can see it coming up a couple of times, and Neil would have touched upon this in his presentation. So DDPM, or a pump motor that allows you to have energy recovery, it's not unknown here. We have the solutions. We have the test areas. There's a lot of historical data going back to wind turbines, etc. So it's not something that's totally alien to us. We believe we will have at some point in the future DDPM. So the ability on a prime mover to have a pump, but it's also a pump motor, which will then recover energy either back through accumulators or potentially, if it's battery driven, to supercapacitors. But for the moment, it's not on the sort of commercial timeline. We are still working through theories and applications that we want to try out on before we sort of start to let it off the leash into the commercial market. So it's still some years away. I wouldn't like to put a timeline on it, but we know what we have to achieve. And I don't know if Aleister, if maybe you have an extra comment to make to that.
I'm not sure if I can add much to it, other than it's kind of one of the advantages of buying into DDP is that we've got technical solutions to suit products now and start solving the energy efficiency challenges in the hydraulic system side of things. And of course, I think the world is trying to work out how it electrifies. And many people, I think as what Neil was talking about in his presentation, have this choice. They feel like they might have a choice to go down some kind of diesel route or an electrified route. And we're presenting, I think, the start of a pathway that we can make improvements to your products and your systems now while they're powered by diesel engines. But all that learning that you have is really just the start of a pathway with digital displacement that by the time, I don't know, maybe the battery costs have reduced, or we can help with your value proposition by allowing you to fit a smaller battery, then the DD technology will be there. And I think by the time you get into electrified systems, even you can do some fairly impressive hydraulic energy recovery into an accumulator. Of course, by that point, you need a motor because you need to be able to accept energy back from your actuators and then motor it back, and then either turn your electric motor as a generator and put energy back into the battery, or send it into a hydraulic accumulator for use later. So yeah, it's a little bit down the roadmap.
Great, thanks for that, Aleister. Craig, Lee, there's a question here around the controller. Basically, can you explain basically what is the controller? The question here, is it a SAL2, or can you explain basically how our controller is set up?
Yeah, well, each pump has its own controller, and And I guess what they're asking in this question is it SIL 2 certified, safety integrity level 2? And today that controller is not SIL 2 rated. It's going to be CE rated, I believe. Maybe Aleister, Craig, you guys can jump in on that, but I believe we're going for the CE certifications. But the SIL portion of the digital displacement in a system, it's going to have to be a system approach versus a component approach.
Perfect. Thanks, Lee. Any other comments there from the team?
Yeah, I was just going to say, Lee, you're correct. The controller is going to be CE marked, and yeah, your answer on the system level safety approach is where we're at just now.
Yeah,
perfect.
I mean, I don't know, Aleister,
Craig,
do we have something on the road? Sorry.
No, on you go, Lee. Please carry on.
No, I was just going to ask. It's possible in the future, if there's enough demand for a SIL 2 rated controller, we could look into it and potentially develop something. But for now, we've got a lot on our plate developing products, and I don't see it on the near term.
Perfect.
Right, and that's something where
Craig,
we can be a bit
please.
responsive to market demand, but at the moment, yeah, we don't. We've got, I guess, enough on our development pathway that we don't need it at the moment.
Perfect. Thank you, gents. Craig, one for you, please. Is there a recommended minimum shaft speed? Is pulsation likely to be a reason for this? Give me a little bit more about the sort of what's going on there in terms of the shaft speed.
Yeah, I have to go back. Sorry for going off piste here, but when we went to the Baumer show, this was the one question that was asked of me, and I didn't know the answer. So I turned to Aleister, and I believe at the moment we are talking in the region of 400 to 500 RPM, but we're obviously trying to work within the general confines of a diesel engine, which is 1300 idle speed. It's obviously when you go to electric drives, we start to look at the speed range there. So that's when the minimum shaft speed would come into consideration.
Yeah,
so I'll ask Aleister.
Yeah, sorry if I can step in there. So I think the question was, is pulsation the reason for limiting the lower shaft speed there? And no, basically it's not. I think truthfully, it probably comes down to a tribological thing. I think I said before, we're not magic. We are a hydraulic machine, like really a lot like any other. We've got sliding surfaces, pressurized, wetted areas. At some point you've got issues of surfaces in close contact that are very highly loaded, and that's going to set our lower limit, the same as a lot of other machines. From a development point of view, historically we've made machines that go down to 0 speed, but from a product launch point of view, with the Gen 2 DDP 096, it's going to have, I can't exactly remember what's in the brochure, but I think it may be 800 RPM or 900, I can't remember, but it's basically targeted at a diesel engine idle speed. And as I said before, the losses of the pump are so low that we don't need to go down to very low RPMs in order to get the energy efficiency. So there's very little penalty for keeping the DDP running, even 1500 RPM. You don't need to go down to several hundred RPM to make the savings. And it's something that in the variable frequency drive industrial world, that's basically what happens there a lot, is you have to take the pump down to really low RPM when you've got low demand, because you're trying to compensate for this really quite high loss of the machine when it's at 0 swash. But that's not the case with DDP.
Great. Thank you, Aleister. Craig, one for you here is at what stage is DDP at right now in terms of delivering this to OEMs? How are we in pilots? Are we looking for production? Where is DDP right now?
Yeah, I think Eric would have mentioned in his presentation that we have the industrial pump currently released, so that actually is going out. It's currently in use within a couple of applications. And the Gen 2, we have pilot customers, we've got projects ongoing, but like anywhere, we would like to have more. We'd like to touch across many different applications. But at the moment, excavators is certainly a very strong focus for us. And as we've discussed during the various breakout sessions, construction, so excavators, wheel loaders, we're talking about mining, electrification across both those areas, industrial market. So yeah, we're getting to a more mature stage, and that's why part of the reason for doing this announcement today is to make everybody aware of what's coming over the horizon next year with the Gen 2 products, and beyond that when we talk about the larger pumps, and then even beyond that again.
Right, thank you, Craig. Just to say to everyone, it's 5 minutes to go, so any last questions, please pop them in to make sure our team gets a chance to have a look at them. Aleister, actually, on that industrial approach that Craig was alluding to, how does this perform, in terms of against industrial servo, for example, plastic injection molding machine? Basically, how well does the DDP perform in these scenarios?
Okay, so I'm not sure if servo here refers to a servo drive or a variable frequency drive, or maybe controlling actuators with servo valves. So I think I've talked a bit about how DDP, if you take it as a pump solution with an induction motor compared to a variable frequency drive, then I would say overall we have a better value proposition than the servo drive, and our efficiency gains will be, I would say, they'd be roughly the same. So I think servo drives quite commonly make some kind of claims around 90% saving in idle losses, and I could say they're cheating a little bit because they're reducing their idle speed in order to compensate for losses in the pump, whereas we would just keep running at fixed speed. If it's referring to servo valves, we've got very high bandwidth control over output, but not on the same level as a servo valve would be in terms of fidelity of directly controlling a load from it. So while we've got, we'll commonly say we've got a 30 millisecond response time, and that's totally independent of pressure on the output, but that's, I think, quite significantly slower than the response that you're going to get on a servo valve in terms of actually controlling load on an actuator or something. So I'm not sure if that's answering that person's question.
No, thanks. That's really thorough. And again, if anything's not quite answered today, please get in touch. Aleister is one of our experts on the ability to set up a meeting, so please get in touch with him there. He can go into more detail, and I'd love to have a chat. Just a quick one here, Craig. Can this be applied to water glycol systems? Is there something you know about? Does anyone else in the team have an opinion here?
Yeah, it comes up periodically, and like traditional variable pumps, they can work with water glycols. It really depends, or any sort of fluid type, depends on the type of mixture. So you can have a half 50% water glycol. You could have a 95.5, such as coal mining, etc. So I think we have to take each one in its merits, but I know traditional technology, what they tend to do is derate the pumps and pressure to manage that situation. We're at an earlier stage that I think we would probably take the fluid types and start to run our own tests on them with regard to the markets that we're looking at, such as injection molding, rubber molding on the industrial. Maybe if you start to go out to marine oil and gas where water glycol is used, that becomes a question. So these are questions that probably we still have to answer properly. But whatever variable displacement pumps can do, then I see no real issue in meeting that, if not bettering it, with digital displacement.
Right, thanks, Craig, on that one.
Okay.
We have a very particular question here. Aleister, for you, in looking at the portfolio, what is our plans for SE3? We obviously touched on the system architecture today. So what is the SE3 plans there for DDP?
So I guess we've touched a bit on our future roadmap, maybe in Neil's presentation, but I think we are not committing directly to revealing a timeline on that at the moment. We've got our technology, we've got our pumps that we're releasing just now, and customers lined up for those, and I guess our kind of target markets that we're aiming for. We're working in the background, as we always are, on new technologies and trying to push that boundary, and we release papers and work with the academic community on that as well, and share that knowledge out there. I think, as Neil said, we won an award for our paper at IFK, because we're really, I think, we're trying to be that, we're really not pushing the technology in an academic way, we're pushing it in a way that means something to our customers and actually brings, I think, really tangible benefits to to the industries that we're targeting. So these aren't R&D things. These are things that are moving on a path towards commercialization. But the further out we look, the less clear I would say it is on a specific timeline for some of those things.
Brilliant, thank you, Aleister. Lee and actually the team, please let me know. There's 2 questions here. First one is around some of our SA2 approach and the pumps mounted manifolds, a series of 2-way poppets. And the question right here is, how is the return of oil handled? Lee, is that something you can answer?
Yeah, I mean, we just have to remember that this is an open circuit pump, not a closed circuit pump. So, the return oil to the reservoir would be handled like any other type of a hydraulic system. So you'd have to have a path back the tank, and it'd be recycled in through the inlet. Anybody else want to add to that?
Yeah, that's perfect.
Okay.
Brilliant. And then just to add, Aleister, we just had a quick back. So the question was around the directional valve in terms of the Servo, just for your reference. Was there anything to add there?
No, I don't think so.
Perfect. Okay, so just to finish off, the very last question here we had is about basically where and what can you learn more? So obviously you have the site today. There's plenty going on there. There's the podcast, there's the videos. There's also a lot going on in terms of our digitaldisplacement.com. We'd love you all to check that out. So thank you for today and have a great evening.
Thank you, everybody.
Yeah.
Thanks,
Thank you.
everybody.
Take care.
Thank you. Bye-bye.
Stay safe.